Okay, so in this video, we're going to continue talking about how to read quantified sentences, and we're going to do so by way of looking at some scope contrasts. So here we have two sentences. We have some x lx and some x nx. And our second sentence is some x lnx and nx. And these sentences are not equivalent, though one can be true without the other being true. Well, basically. The first says that something is lonely and something is a novelist. There's a thing such that it's lonely, and there's a thing such that it's a novelist. The second says something is both lonely and a novelist. So in the top one, the conjunction has scope. It's a conjunction of two existential quantifications. In the bottom one, the existential quantifier has scope. It's an existential quantifier of a conjunction. So the first says that one thing is L, and it also tells us that one thing is N, but it doesn't tell us that the same thing is both L and N. That's consistent with the first sentence. If that were the case, if there was one thing that was both L and N, then that sentence would be true. But it would also be true if nothing was both L and N, but there was a thing that was L and a thing that was N, a different thing in that case. Whereas this tells us that one thing is both L and N. So the first sentence is silent on the question of whether or not L and N overlap. It says there are things that are L going around and there are things that are N running around, but do the properties of L and N overlap? Who knows? Maybe they do, maybe they don't. I have nothing to say about that. Whereas the second sentence is, oh, I have something to say about that. I would like to add that there is one thing that is both L and N. So if the bottom one is true, then the top one is true. If there's a thing that is both L and N, then there's a thing that's L, and also there's a thing that's N, but not vice versa. So the bottom one is strictly stronger than the weaker one. The bottom one implies that, the bottom one implies the top one. Okay, now we have for some x lx or some x nx, and some x lx or nx. So this says everything is lonely or everything is a novelist. And this thing says each thing is either lonely or a novelist. Well, here the disjunction has scope, whereas here the quantifier has scope. So what's going on? Why are these not equivalent? Well, so this says that everything is in the category of L, or everything is in the category of N. And remember that it's an inclusive or, so maybe they're both true, and everything is in the category of both L and N. But it says it definitely takes all of the things, and they're in at least one of those two categories. There's a category, and all of the things are in that category. This says each thing is L or N. So I'm L or N, and you're L or N. So it could be that everything is L, and then the bottom sentence would be true. And it could also be that everything is N, in which case the bottom sentence is true. But here's another possibility. Half of the population is L but not N, and the other half of the population is N but not L. So apparently novelists are really popular, everybody loves novelists, but everybody else is disliked. So, if you are, there are two ways you might be. You might be a lonely or you might be a novelist, but not both. So in that case, the bottom sentence is true. Each thing is either lonely or novelist. But some people are novelists and some people are lonely, and others are lonely, but neither are both. And so the top sentence is false. It's not true that everything is lonely. And it's also not true that everything is a novelist. And so both of the disjuncts are false. And so here we can see that that they say different things. In this case, the top one is stronger because it says dump everything into this one category or dump everything into another category, or maybe both. But there's one category that everything is in. And if that's true, then if you're lonely, then it's true that you're lonely or a novelist. And if you're a novelist, then it's true that you're lonely or a novelist. And so if everything is in one of these two categories, or if there's one category that everything is in, then the disjunction is true of all of the things. But as we saw, it's not vice versa. The top requires that there be one category that they all fit into, whereas the bottom one does not. It says everyone fits into at least one of the two categories, but it doesn't say everyone or everything fits into one of the categories. As I was saying, right, so I used the word implies before, and I think I've said this. I just want to remind you that square, therefore circle is valid. That's equivalent to saying that square implies circle. And what do we mean by saying either of those things? We mean that on any interpretation of the non-logical vocabulary, if square is true, then so is circle. So now we're going to look at some different combinations of these, a few other combinations. So here we have for all x, fx, and gx. We have for all x, if fx, then gx. We have some x, fx, and gx. And we have some x, if fx, and gx. So for all x, if fx, and gx implies all three of the others. I think it pretty clearly implies for all x, fx, and gx, some x, fx, and gx. If the conjunction is true of everything, then the conjunction is true of at least one thing. Why does it imply everything is such that if it's f, then it's g? Well, if everything is green in a frog, then everything is green, and so the consequent of the conditional is true, whichever object we pick, and so everything is such that if it's a frog, then it's green. And for the same reason, if everything is a frog and green, then there's a thing such that if it's a frog, then it's green. And so there's something, and so the existential quantification in the bottom is true as well. Okay, now for all x, if fx, and gx also pretty clearly implies some x, if fx, and gx, because if each thing is such that if it's a frog, then it's green, then something is such that if it's a frog, then it's green. And if something is both a frog and green, then there's a green thing, whichever one it is. And if fx and gx is true of that thing, because the consequent is true of that thing, and that makes the conditional true of that thing. So the top left implies all three, and the bottom right is implied by all three. The top right and the bottom left are independent of one another, though. And these different things are important. So let's think about what these different things actually say in a little bit more detail. So some x, fx, and gx. What does that say if we mean f means frog and g means green? Think about how you might express that in English, and it might help to write something down. In fact, I would like you to pause the video and write something down and restart it once you're done. So what this says is that everything, you might think it means everything is a green frog. Well, yeah, so that's what it means. It means everything is a green frog. Everything is a frog, and everything is green. So it says that I'm a green frog, and you're a green frog, and everything else is a green frog. So it's a pretty strong statement. Not something you'd probably say, because it asserts this conjunction is true of everything. Okay, what about the top right? Well, the top right says for all x, if fx, then gx. What does that mean? For each value of x, if that thing is f, then it's g. Each thing is such that if it's f, then it's g. So again, I'd invite you to pause the video and write something down, what you think it might mean in English, in a more compressed form. So the easiest way to say this is every f is g, so every frog is green. I will talk more about why that's why those two sentences probably have the same meaning in the next video. How about the bottom left? Some x, fx, and gx. Again, pause please, write something down. And what it means is some frog, oh, sorry, that was too early. If you want to symbolize every f as g, then for all x, fx, and gx is too strong, because it doesn't, if every frog is, if everything is a green frog, then it's certainly true that every frog is green. But every frog is green does not say that everything's a frog, and it does not say that everything is green. It says each of the frogs is green, but there may be all sorts of other things besides the frogs, and they don't have to be green. And that's totally compatible with saying every frog is green. But if I say everything is both f and g, then that it can't happen that there are any, let's say, blue emus. Blue emus are fine They're totally compatible with every frog is green, but they're not compatible with everything is a green frog. So the top left is too strong to symbolize most of the things we would say normally. Okay, now so back to the bottom left. This says some frog, some F is G, some frog is green. The bottom right says something is such that if it's a frog, then it's green. So this is super weak. That conditional, if fx then gx, that conditional is true of me. Since I'm not a frog, the antecedent is false of me. If a conditional has a false antecedent, it's a true conditional. And so the conditional is true of me. The conditional is true when x refers to me. So there's something such that it's such that if it's a frog, then it's green. Whether or not there are any green frogs at all. If there are any non-frogs, the bottom is right. The bottom right symbolic sentence is true, but it wouldn't necessarily be the case that some frog is green. So for some frog is green, we need the bottom left. And the problem is that the bottom right is too weak. So you want to, we'll discuss these in more length, but when we're symbolizing, what this is pointing out is we need to get the existential we need to get the quantifier right, but then we also need to get the connective right. And it's almost always the case that a universal connective is always, if you're symbolizing over a conditional, whereas an existential is almost always over a conjunction. And in the next video, we'll see some examples as to why that is in more detail.